The honeycomb conjecture is a theorem in Euclidean geometry. It states that if a surface is divided into equal areas, the total circumference of the edges is at least equal to the regular hexagonal honeycomb subdivision. The conjecture was proved in 1999 by the US mathematician Thomas Hales. In other words, the theorem says that the honeycomb is the optimal shape if you want to divide an area into equal areas while using as little material as possible. Research has shown that with the least amount of material, the largest possible capacity and the maximum amount of enclosed space can be achieved, also providing the greatest stability. Apollonius of Perge already mentioned this fact in one of his books around 180 BC. Marcus Terentius Varro wrote around 36 BC as a possible explanation. The honeycomb shape can have two reasons. First, the 6 legs of the bees fit into it best. Or second, the ratio of the circumference to the enclosed area is the smallest. Both theories were still being considered long after he had passed away. For example, the Swiss bee researcher François Huber described in 1792 that honeycombs are initially round during construction and only later acquire their typical hexagonal structure. An opinion that has since been refuted was that the bees build the combs round and the body shape and temperature of the bees then bring them into their shape. The example of this effect was often cited as the boundaries between adjacent soap bubbles. Although the effect was disproved in honeycombs, the construction of these structures still cannot be fully explained today.